Hi everyone, today I'll be going through the 2021 Further Maths Exam 2, the Networks and Decision Mathematics section. Question 1, the diagram below shows a network of roads from Lee's home to the airport. Her home and the airport are labelled as vertices on the network. The vertices P, Q, R and S represent road intersections. The number on each edge represents the distance in kilometres along the section of road. What is the degree of vertex P? So to work out the degree of vertex P, we calculate the number of edges that are connected to P. So that's one edge over here, two edge over here, three edge over here. So the degree of vertex P is 3. B. What is the shortest distance in kilometers between Lee's home and the airport? So we got to find the shortest distance between the home and the airport. So to do this, I have a method, like a Dirac algorithm method I use on a graphical method. So I can just show it to you right now. So you start off from home and you write the numbers. So you write 50 over here to every vertex you can reach. So we can go to home and vertex P, 15. Then you circle the smallest number and that vertex. So 15 is the smallest number and the vertex is P. Then you then you calculate the distance from that vertex to the next vertex. So 15 plus 20 is 35. 15 plus 25 is 40. So therefore our next smallest number is 35. So then you calculate the distance from that vertex to every other uncircled vertex. So R to S is 47, R to Q is 45, and we can't go back to P because there's a circled vertex. So therefore the next smallest number is 40, so circle 40 in vertex Q, and 40 plus 35 is 75. Next smallest number is 47, so circle vertex S and 47. 47 plus 8 is 55. Our next smallest number is 55, so therefore the shortest distance from the home to the airport is 55 kilometers. C. What is the mathematical name of the edge that forms the drop-off zone? So the drop-off zone is over here. Let's just get rid of this. The drop-off zone is the airport linking an edge that goes back to the airport. So you should know that an edge that goes back to its same vertex is called a loop. So therefore the mathematical term is a loop. So that's just something you should know. D. An incomplete adjacency matrix for the network on page 20 is shown below. Write the missing 4 elements in the spaces provided in the matrix. So basically we need to represent the networks in this matrix over here. So this could represent home to home or the other way around, home to home. Doesn't really matter because there's no arrows on the edges. So home to home. We can see over here that there's no loop at home, so therefore that would mean there's a 0. P to home. P to home, we can only see there's one edge there, so therefore there'd be a 1 over there. Home to Q, so we can see from home to Q there are no edges directly connected to home to Q, so therefore that is a 0. Home to P we can see there's 1, so 1 over here, home to P. There was only one edge connecting them, so therefore 1 goes there. Question 2, Lee must book a last-minute flight from Melbourne to London. There are no direct flights, however, TravelSafe Airlines has flights available from Melbourne to London via Brisbane, Hong Kong, Abu Dhabi, Amsterdam, and Los Angeles. The network below shows the maximum number of seats still available on these flights. A cart labelled Cut 1 is also shown on the network. How many different flight routes are available from Melbourne to London? So to do this question, we just need to see how many routes we can get from M to L. So as we can see, this is 1 over here. We just use a highlighter. 1 route over here. Another one could be over here. Another one could be going through M to H and then via A to L. And another one could be M to A to L. Another one could be from M to AD to A to L, and another route could be from M to AD to L. So in total, that's 6 possible routes from M to L. You just really got to visualize it and just see how many ways you can get from M to L. When considering the possible flow through this network, different cuts can be made. B, what is the capacity of cut 1? So cut 1, we just got to calculate arrows that move forward. So basically, we're calculating the arrow for 12, 8, 14, and 20. It wouldn't be 10 because if we block all the number of seeds from 20, that means there can't be any flowing through this arrow. So therefore, you'd only block 20, and you wouldn't block 10. So if you calculate that, it's 20 plus 14 plus 8 plus 12. That is the capacity of cut 12. Of cut 1. So you do that in your calculator. 20 plus 14 plus 8 plus 12 gives you 54. So therefore, the capacity of cut 1 is 54 seats. C, what is the maximum number of seats still available to travel from Melbourne to London on this day? So basically, all we need to do is find the minimum cut. The minimum cut is, which I've already calculated, was 5, 8, 14, and 20. So it goes through arrow 5, that arrow that has 5 seats, 8 seats, 14 seats, and 20 seats. So basically, to do this question is just trial and error. You just got to keep trying to look for the minimum cut. But the capacity of this cut is 47, and that is the minimum. That is the minimum cut. So that would be the maximum number of seats available from Melbourne to London. So 47 is the maximum number of seats. 47 seats is the maximum number of seats available from Melbourne to London. If you don't know how to do cuts, please leave a comment down below, and I will try get back to you as soon as possible. Maybe I could just make a video explaining cuts if that's what you need to help understand this question. D, Travel Safe Airlines can add 8 extra seats to one of its flights in order to allow 8 more passengers to travel from Melbourne to London on this day. Name 2 cities between these extra seats could now be available. So basically what this question is saying is you could add 8 extra seats to one of the arrows, and the minimum cut, this cut over here, would still be the minimum cut. So this cut over here would still be the minimum cut if we add 8 edges to one of the arrows. So that's what the question is trying to say. So basically, we can do trial and error. So let's say you add 8 seats to this arrow over here. That would make it 13. So this cut is no longer the minimum cut. This cut over here is no longer the minimum cut if we add 8 to that arrow, because the new minimum cut would just be 12, 8, 14, and also go through 20. So that would, the cut in green is now, let me just calculate it, 13 plus 8 plus 14 plus 20. So that is 55, the cut in green, currently. But now we need to look for potential new minimum cuts that could arise as a result of increasing the number of seats on this arrow over here. And if you do that, then this is a potential, this is a new minimum cut that arises. So that minimum cut in blue is 12 plus 8 plus 14 plus 20, 54. So the new minimum cut is 54 if we add 8 to the arrow between M and B. So therefore, if we add 8 between Melbourne and Brisbane, that would not result in 8 extra seats. Instead, that would result in 7 extra seats, because our new minimum cut is 54. So 54, if we say our new minimum cut was 54, that's 54 minus 47. 54 minus 47 equals 7. That's an increase of 7 seats. However, we want 8 extra seats. So therefore, we obviously know that adding 8 here is incorrect. So let's trial another arrow. So we'll just trial the arrow in between Hong Kong and London, because we know that in order to add 8 extra seats, the new cart, the additional seats have to be added to an arrow along the existing minimum cart. So let's try adding 8 seats to Hong Kong and London, so that's results in 16. Now, if you do that, the minimum cart remains the same, I believe. I can't find anything else that could potentially result in a new minimum cart. No, there does not look like anything else. So basically, the minimum cart will remain along this path. This cart will remain the same. So therefore, the new minimum cart would be 5 plus 16 plus 14 plus 20. So the new minimum cart is now 55. Now, if we compare that to our previous minimum cart before we added the 8 seats, it was 47. So if you do 55 minus 47, that gives you 8. So therefore, that confirms that if we add 8 extra seats so that confirms if we add 8 extra seats between Hong Kong and London, that would result in an increase of 8 extra seats on the minimum cart. So therefore, we can confirm that it is between Hong Kong and London. Question 3, Travel Safe Airlines is planning to renovate a passenger terminal. This project will involve 12 activities, A to L. The directed network below shows these activities and their completion time in weeks. The completion time of activity J is labelled X, as we can see over here. The minimum completion time of this project is 20 weeks, so therefore that's basically telling you that the box at the finish would have an earliest start time of 20 and a later start time of 20. So therefore, it says what is the value of X. So to determine the value of X, we need to complete the earliest start time of each box, so for each activity. So if we start at 0, and then 5, 4, 6, 5 goes in there, 6 would go in here. We've got to do 5 plus 3 is 8. Biggest number goes in the box. 5 plus 3 is 8. 8 plus 7 is 15. We've got to wait to determine what the number is over here. 8 plus 7 is 15. 6 plus 8 is 14. And 6 plus 6 is 12. 12 plus x is 12 plus x. So now we need to determine the value of x. So from this step over here, we can backtrack and determine what the latest start time is. So we can now determine the latest start time for activity L. So that'll be 20 minus 3 is 17. And since there's only one arrow here, we would know that the earliest start time for L would also be 17. So basically, to determine what number goes into here, we need to understand that the number in the earliest start time for K, so the number in the earliest start time for K plus 1 should equal to the earliest start time for L, which is 17 in this box over here. So it equals 17. So it can't be 15 because 15 plus 1 is not 17, and it can't be 14 because 14 plus 1 is 15. That's not 17. So therefore that leaves us with 12 plus k. So 12 plus k will go into this box, and from there we can determine what the value of x is. So 12 plus k equals 12 plus k plus 1, so the number 12 plus k plus 1 over here equals 17. So 13 plus k equals 17. K equals 4. So therefore the value of k is 4. Now with B, complete the following sentence by filling the boxes provided. So now that we know that k is 4, we know that 12 plus x would equal to 16 because x is 4. So therefore we can substitute 12 plus x is 16. We can substitute the value of x is 4, just so we know. And that would be 16 because we know that x is 4. So 12 plus 4 is 16, so that would be replaced with 16. 16 plus 1 is 17 over here. So now we need to complete all the latest start times for these activities. So 20 minus 3 is 17, which we've already done. 17 minus 1 is 16. 17 minus 7 is 10. 10 minus 3 is 7. You gotta wait there until we can determine if there could potentially be a smaller number coming in from this arrow. So go back over to 16. 16 minus 7 gives us 9. 16 minus 8 gives us 8. 16 minus 4 gives us 12. 12 minus 6 gives us 6. The smallest number goes in the box when we're calculating the latest start time. So 6 goes in the box. 6 minus 6 is 0. 0 is there. And now we can go back to here. 9 minus 3 is 6. So smallest number goes in the box. 6 is over there. 6 minus 5 is 1. And 9 minus 4 is 5. So from here we can determine what the activity that has the longest float time. And then so the float time is basically equal to latest start time minus earliest start time, which is basically the number on the right box minus number on the left box. So for activity J, we'd look at the box to the left of that activity, and we can see here that it has a float time of 0 because latest start time minus the earliest start time is equal to 0. So we can see that activity B appears to have the longest float time because we can see that the latest start time is 5, and we can see that its earliest start time over here is 0. So 5 minus 0 is equal to 5, and therefore that is the greatest float time on this network over here. So we can conclude that B has the longest float time of 5 weeks. C. How many activities could have their completion time increased by 2 weeks without altering the minimum completion time of the project? So basically, we're looking for activities that have a float time of 2 weeks or more. So if we look over at the graph over here, we can see that activity B has a float time of 5 because the float time of activity B is equal to 5 minus 0. Latest start time is 5 for B minus the earliest start time of 0, which gives us a float time of 5. So therefore that would be one of the activities. So also another activity that has a float time greater than 2 is activity E. As we can see, the latest start time is 7, so the float time for E would be equal to 7 minus the earliest start time of E, which is 5, as we can see. So minus 5, that gives us an earliest float time of 2 weeks. So therefore it can also have its time increased by 2 weeks without affecting the completion time of the project. And we can also see that the float time of G is calculated by latest start time minus earliest start time. Latest start time of 8 minus earliest start time of 6 gives us 2. So therefore it could also be increased by 2 weeks without affecting the completion time of the project. And we can also see that the float time of I is equal to 10, the latest start time minus 8, earliest start time. So 10 minus 8 is 2. So therefore I could also be increased by 2 weeks without affecting the minimum completion time. So adding all those up, that is 4 activities. So therefore 4 activities could have their completion time increased without affecting the completion time of the project. D. TravelSafe Airlines has employed more staff to work on the renovation project. This has ensured that no activity on the network above will have an increase in completion time. However, the completion time of activities G and H are each reduced by 2 weeks. How will this affect the overall completion time of the project? So we know that activities G and H are reduced by 2 weeks. So if we reduce G by 2 weeks, it becomes 6. And if we reduce H by 2 weeks, it becomes 4. So now you got to complete the So now you got to complete like the earliest start time for each activities going forward from G and H. So if we know that from 6 as our earliest start time over here, plus 6, that would now result in 12 being over there. And if we've changed this to 4, we can do 6 earliest start time plus 4 and add a new box which represents the adjustments that have been made by reducing G and H. That would result in 6 plus 4, which is 10, and a new box over here, which is so 10 plus 4 over here means that 14 would be over here. So, and we can see that 15 has remained unchanged. So the biggest number now is 15, because 14, 12, 15 are new options to choose from as a result of reducing G and H by 2 weeks. So 15 is our new earliest start time for activity K. And if we draw a new box over here, this has remained unchanged. And 15 plus 1 is 16. So therefore, largest number is 16. Put 16 in the box. 16 plus 3 is 19. So therefore, our new minimum completion time is 19 weeks. So the question is saying, how will this affect the overall completion time of the project? So the completion time of the project will be reduced by 1 week. 1 week, and I'll just put in brackets. The new completion time is 19 weeks.